Now that you know a simple way to solve the data association problem, I'll go over the quiz, and you'll learn about some of the advantages and disadvantages of the nearest neighbor technique. We'll come back to this. Nearest neighbor is great because it's easy to understand and implement. Just take the closest measurement. Here, we are showing the association between the closest LiDAR measurement and each map landmark with the red circles. However, simple techniques have some disadvantages, in that they are not as robust to difficult scenarios. For instance, a high density of measurements would make this technique very prone to errors, because one map landmark could be really close to multiple measurements. It's unclear which feature in this image corresponds to these map landmarks. In addition, the nearest neighbor algorithm is quite inefficient, because for each landmark, you have to search through all of the measurements to find the one with the minimum distance. Therefore, the complexity is O of mn, where m is the number of map landmarks, and n is the number of sensor measurements. If there are a lot of sensor measurements or landmarks, nearest neighbor could become quite slow. Additionally, if a sensor is very noisy, you could easily match a spurious feature, one that doesn't actually correspond to any object in the real world, to a map landmark. The landmark on the right has an incorrect association due to sensor noise. You can tell that this other match is correct because it matches the geometry of this other landmark match. Another disadvantage of nearest neighbor is that it is not as robust to errors in the vehicle position estimate. If the vehicle position has some errors, nearest neighbor will also incur some errors. Here, the car is shifted to the right, so the measurements are also shifted to the right, as shown with the purple lines. However, nearest neighbor will not see this pattern and will pick some incorrect correspondences, which are circled in black. Another disadvantage of nearest neighbor is that it does not take uncertainties of the sensor into account. For example, let's say you have a radar sensor that has very precise bearing measurements and not as precise range measurements. The green ovals here represent the uncertainties in the range and bearing dimensions for these radar measurements. Nearest neighbor would pick this match, but this other match is more likely, given that the sensor is very accurate in the bearing dimension and not as accurate in the range dimension. So, let's summarize. The nearest neighbor data association technique is easy to understand and implement, and it works well in many situations. However, it is not as robust to large densities of measurements, sensor noise, or errors in position estimates. It can be inefficient to compute and also does not take sensor uncertainties into account. Now that you know how to associate the sensor measurements you get with landmarks in the map, next you'll learn how to implement the update step of the particle filter.